Okay. Hi, my name is and Sarah Albrecht, and I will be doing my final presentation on my term paper. And the topic that I chose for my term paper was fluorosis in Assam, India. So yeah. Um, so this is the state of Assam. It is in northeastern India. Um, It contains huge gorges and a large floodplain from the river Brahmaputra, which you can see in um, that center picture. It's in northeastern India and it's just south of the eastern Himalayas, so a lot of water flows from the Himalayas down onto this floodplain. Um, Assam also experiences a lot of flooding because there's a huge amount of rainfall in this area. And the river floods from the rainfall. Um, so this oftentimes makes the river water contaminated with chemicals or algae or like dirt or sediment. And it oftentimes makes the water quite undrinkable. So a lot of the people who live in this area drink the groundwater. So but from the groundwater, there's also something wrong with it. So it has a lot of fluoride dissolved into it, um, which causes an overexposure to this fluoride in the people who are drinking this daily. It's called fluorosis. It happens to everyone who drinks this water, but it's much worse in developing children as their skeletons are just like not as hard and they're just not as developed. Um, it causes it affects it only not only does it affect the teeth, which you can see in this left picture. That's like a very mild case of dental fluorosis, and then in the picture on the right, um, it's quite a severe case of skeletal fluorosis. Um, it affects the skeleton by hardening and thickening the bone, which results in an increase in frequency and chance of fractures. It also contributes to joint mobility, um, impaired joint mobility, and in very, very severe cases, it can cause severe mobility limitation and crippling deformities. And especially in children who are drinking this water so much, um, based in like the first 8 years of life when the skeleton is developing quite fast, that is when the fluorosis hits um, the worst because it can cripple children and just cause a lot of very bad deformities which will never be able to be fixed. So, according to the World Health Organization, 1.5 parts per million or 1.5 milligrams per liter of fluoride in drinking water is the global standard. I would say that it's a little bit more of a global like maximum because you generally want you want less than 1.5 ppm. But in some parts of Assam, you get about 15 parts per million of fluoride, which is about 10 times the amount of fluoride that other people are getting, which is why fluorosis is so um, prevalent here. So, one solution to this problem is that um, in order to filter out the fluoride, you can use something called a reverse osmosis filtration system, which removes contaminants such as fluoride. It also removes like heavy metals and other heavy elements. So in this diagram, you can see that pressure forces the contaminated water through a semi-permeable membrane or an RO membrane. and it flows from one side to the other, producing clean water. So this RO membrane removes dissolved solids like fluoride. Um, as the fluoride is dissolved into the groundwater, um, it comes from the rocks surrounding the groundwater storage areas. Um, and this filtration system is actually very easy to use because you just dump the water in and it comes out eventually uh, as clean water and you can drink it. Other solutions are to dilute the groundwater with rainwater to lower the concentration of fluoride in the drinking water. I think that this solution is very accessible to a lot of the rural and agricultural villages in this area of India because they can just set out like a large tray or a large tub or bucket or bowl to collect the rainwater. And then they can just mix the well water and the rainwater together to hopefully dilute the fluoride and make the water a little bit healthier to drink. Another solution is, well, this isn't really a solution, but it's just to reverse, hopefully kind of reverse the symptoms of fluorosis because fluorosis is actually incurable. So once somebody is fully exposed to that much fluoride, um, the effects on their teeth and skeleton are incurable. They're non-reversible. So that's why it's so important for younger kids to reverse symptoms. So they can use vitamin tablets like vitamin C and D um, to strengthen their bones and their immune systems, um, and also just feeding feeding them fresh, clean water um, should hopefully help kind of reverse the symptoms of fluorosis. Um, However, there are barriers to implementation of these solutions, specifically the reverse osmosis filtration system, because the average home income in a village called Tabajuri, which is in Assam, it's about $1.65 USD, um, which makes the individual household RO systems quite infeasible. Um, it makes it very unaffordable for these families to buy them because these systems cost from around 200 to 600 USD, which is about 120 to 360 times the amount of money a family makes in a day. Um, and that doesn't even count shipping and transportation and like figuring out how it connects to taps. So it's quite difficult for them to get these filtration systems. Um, the state of Assam also has the financial inability and also lack of government infrastructure to successfully implement a program to distribute these RO systems at so large a scale because many people need these filtration systems. I think it's about 400,000 people in Assam need um, drink this groundwater. So they would need many RO systems, and it's just the government does not have the infrastructure to successfully implement such a large program. They also need to make them very affordable or also free, and they just don't have the financial ability to do that. Um, with the filtration systems, one solution to the how each individual household cannot afford one system each, um, the government could implement community filtration systems. So you could place them near wells or near taps, and multiple families or even entire villages could use these filtration systems. Um, and I think this would make it a little bit easier um, for villages to get them. and for people to have cleaner water. So yeah, I think the community filtration systems would be very helpful, but still it also runs into the barrier of how will the government get it to them, or how will they be able to purchase them? And these are my works cited. Um, but yeah, that's all I have to say about my presentation. Yeah, I hope you like it. Oh my God, sorry. Okay.